All right, we're live.
You just read down the paper?
Yep. The first one that we need to do is we need to make sure each team member can define radians. So can anyone define radians? So is that the radians? Is that the the degree or inside of the angle?
So it's just a unit for an angle.
Yeah.
It's the unit for an angle?
Yeah.
Right on.
Yep.
All right. Next one. The unit circle I know, let's see, Tess or Holly, you filled out the unit circle correctly?
Yep.
Awesome. I saw that. What about you, Tessa? Have you filled out the unit circle?
Yep, I did all mine. You can see it.
Awesome. Good job. Was there anything that you guys didn't understand vocabulary-wise?
Not really. It was just kind of a good review.
Right on. Cool. So should we just move on to the problems then?
Yeah.
So Holly, I know that you know it really well, and so I was wondering if could you do the first problem and explain how you get your answer?
Sure. So you find the 4 pi over 3 on the circle. It's located at the 240 degree mark. And then the x is the cosine and the y is the sine. So it's negative square root of 3 over 2. And that's it.
Cool.
Yeah. Seems pretty easy.
Right on. So do we go through each of the problems together, or do we just?
Yeah, it says that's what you're supposed to do. G the T on the bottom.
All right. So find sine of 7 pi. So looking on the chart, that would show up as 7 pi would be 180 degrees, right?
Yeah.
Cool. And so the cosine is x and the sine is y. And what else am I missing here? Is that it? Is that all I need?
I think that's it.
There's 0.
What was that?
Someone want to do 7 pi over 2?
I'll try it. Okay, so you guys might have to help me out with this because I haven't taken trig since like junior year of high school.
Same here.
Okay, so looking at it, find 7 pi. Looking at your chart. Anybody, you want to help me out with this? I'm still trying to understand it. I'm having a little hard time.
Hmm.
Try to go for it. You want me to explain?
What was that? What'd you say, Holly?
Want to do it or explain it?
I couldn't hear you. Your voice kind of cut out, Holly.
Let's see if this will work better. I use my headphones.
Say something. Yeah, that sounds better.
So this works now?
Yeah.
Okay, so I'll use my headphones then. Okay, did you want me to explain the 7 pi over 2? Or do you want to do it?
Explain it again.
Okay, so you have your circle, right?
Right.
So if you just count, you go this way. You go 0, you go 2 pi over 2, 2, 5 pi over 2, 6 pi over 2, and then 7 pi over 2. So you get to the bottom. And then you're looking for the sign, so it's your y, so it's -1. And that's how you do it. So you just count around.
Okay.
Does that make sense?
That does make sense. I actually didn't think about that.
It's a lot easier.
Yeah,
You can
definitely.
also do the cheat way. Do you know how to do the cheat way where you don't have to count all the way around like 5 times?
Mm-mm.
So you go to the bottom, so it's 7 pi over 2. 2 times 2. You just do that with all of them. So denominator times 2. And then you subtract from the top. So you do 7 minus 4 over 2, which is the exact same as the bottom that you used.
That
So you
makes
can do
sense.
this. Yeah, so you can do the same thing on 7 pi over 4 and stuff. You can use it for any of them if you don't want to count around the circle or much. Anyways.
Cool.
So want to do the next one?
-9 pi. All right. So that would be -9 pi. Would that also be at 180 degrees?
Yeah, it's the same.
That's what I was thinking. So it'd be at 180 degrees. Sorry? Oh, sorry. I didn't hear
Sorry,
you.
my roommate was talking.
Oh, no, you're good. I thought I had switched to another screen, so I thought you were talking to me.
No, I'm sorry.
So let's see. The cosine would be x, which is -1 there, and
I'm still listening. Sorry.
sine. Oh no, I wasn't pausing. And then yeah, sine would be the y, which is 0, right?
Mm-hmm. Except for you're looking for the cosine.
Sorry.
You're looking for the cosine.
And the cosine is -1, right?
Yeah, so that's your answer.
Oh yeah, that's what it said. Find cosine. Okay.
Yeah, cosine -5.
Didn't need to find the sine. Okay.
Yeah.
And who would like to find the cosine of pi over 3?
I'll try it. So pi over 3, if you look on your chart, there's like a line for pi over 3. Right? Pi over 3, 60 degrees. And the cosine is square root of 3 over 2. Is that right?
No.
No.
It's the x. So it's the first one.
1/2.
Yeah, the cosine is the x.
Okay.
Yeah, cosine's x, sine's pi. If it's easier, go alphabetical because C comes before S.
Mm,
So it's
I like that.
cosine, then sine.
Okay,
It's
that
easier.
makes sense.
Cool.
Yes, it's a half.
Cool.
Got this down, Holly.
Yeah, I already did all the homework for it. Okay.
So find the cosine of 7 pi over 4. Would you like to do that one, Holly?
Sure. 7 pi over 4 is 315 degrees. And so it'd be square root of 2 over 2.
Nice.
Yep. So I want to do negative 5 pi over 4.
5 pi over 4. So I can do that. 5 pi over 4. So that would be 225 degrees on the chart. And which one are we looking at? We're doing sine.
It's negative.
Oh, it's negative.
Negative 5 pi over 4.
Negative 5 pi over 4. Okay. So that would mean, how do you do that then? If it's, when it's negative 5 pi over 4. Is it, oh, would it be 45 then?
Is it just opposite? No?
Dang it.
That's what I was thinking.
So you get your circle. You go this direction for positive. So that's why you go the pi 6, pi 4, pi 3. If it's negative, you go this direction. So pretty much if you flip it across the axis, that's your negative.
So you got to flip it
So-
across the x-axis?
Yeah, so if
If
you
it's
see
negative?
the 5, so the 5 pi over 4 is right here.
Yeah.
Flip it, so it'd be right up here.
Oh.
So
Where
what
the
it would
3
be
pi over 4 is.
135.
Yeah, it'd be the 135. So you just count this direction. So
Okay.
yeah, so you can count it. Go 1, 2, 3, 4, 5.
Okay.
Oh, thank you for that. That is good to know. And I
Yeah,
guess
go
that's
for
why
it.
I didn't need to worry about it on the negative 9 pi because it was on the axis.
Mm-hmm.
Yeah, so technically you should have counted this direction, but
Yeah.
it doesn't matter if it's pi.
Okay, cool. That's good to know.
Okay.
And then who'd like to do the
Thanks.
last one?
I'll do the last one. Okay. So 19 pi over 6. Oh boy. So with this one, would you have to count? Like we did with the first couple few?
You
Does that
can,
make sense?
yeah, or you can use the cheat way. Whichever way is easier for you.
What's the cheat way again? You
So you do the bottom, which is 6,
Yeah.
times 2, which is 12. So you
Uh-huh.
do 19
And
minus
subtract.
12. So you get 7 pi over 6, which has a spot on your circle.
Right.
Oh, okay.
So it's 210 degrees. I'm gonna find the cosine,
Yep.
so it's negative square root of 3 over 2. All right.
Yep, that's it.
Okay. Cool.
Yay.
Cool. Right on.
Okay. Second section.
Yep.
Mm-hmm.
Did you guys do that?
Einstein's theorem. Answer the following questions as a team. Find sine of pi over 3 and cosine of pi over 3. So basically the same things that we have been doing.
Yep.
For this first question. So let's see,
Yep.
pi over 3, that's going to be 60 degrees. Now the cosine wait, yeah, 60 degrees. So the cosine would be 1/2, and the sine would be the square root of 3 divided by 2, or over 2. If that sounds correct to you guys. Square each value and find the sum. Oh, so right now we're going to be finding... Okay.
Yep.
So we got to square each value and find the sum, huh? So we got 1/2, and we have the square root of 3 over 2. Squared. So that's 1/4. And
Guys, marker board is genius.
I know. It's my favorite. Makes life so much easier.
Yeah, for sure.
Math done. Equals 1.
is it? Let's see. So for the other one, did you get 1/4 and 3/4 for both of them?
Yep.
Cool.
Should always equal 1.
And then you had them. Yeah. Oh, and they. Oh, yeah. I remember that actually.
Yep.
Awesome. Thanks, Holly.
Mm-hmm.
What did you find? Do you think this is true always? So, we understand that if they're squared and then they're added together, they should always equal 1, right?
Right.
Yep.
Cool. The same process at pi over 4 and again at pi over 6. So pi over 4 is at 45 degrees. And yeah. If you want, I could do the pi over 4, and then Tessa, if you want to do the pi over 6. And because did you do the first one, Holly?
Yeah.
Nice. So you'll check since you're the one that knows what's going on, you can check if we know what the heck we're doing.
Yeah.
Okay. Go for it.
Okay, so okay. I'm ready to share mine. So at pi over 4, the cosine and the sine, they're the same. It's the square root of 2 over 2. And so, I don't know if you guys see that, but yeah, square root of 2, if you square root that, each of them, comes out with 2/4 plus 2/4, which equals 1.
Yep.
Okay, and then at pi over 6, cosine is 1. Oh, is 3. Square root of 3 over 2, and 1/2. So you can see it right there.
Yep.
And then you square both of them, and then you add it up, and you get 4 over 4.
Yep.
Cool.
Yep. That's it.
So what did you find? That it always equals 1, right?
Yep.
Yep. That's it.
Cool. And why does it work that way?
No idea. It's just how it works.
It's just how it works. Yeah. Well, sounds good to me.
Yeah. It's just because each of the triangles they make are of the same area.
Oh yeah.
Triangle with it. It always
Right.
meets the same area. That's why they're all one.
Cool. So let's see. So
What are we supposed to do for number 3? There's
that's what
no
I'm wondering.
question in that. It's just a paragraph.
Yeah.
That's what it looks like. In preparation, one thing you have to know is this isn't. Is that anything? So it equals 1 since the cosine function is the x value. But yeah, that makes sense because x squared plus y squared, the c squared, what would be, or a squared plus b squared equals c squared, where c squared is the hypotenuse. In the unit circle, it's always 1. And so that makes sense why x squared plus b squared, or a squared plus b squared, or x squared plus y squared equals 1 all the time. You don't need to put c squared in there because it's always going to be 1.
Right.
Yep.
That's cool.
That works.
But anyways, use your book, section 5.2, to discuss the formula for the motion of a spring and go through the practice problem.
Anyone know how to get to that?
No. Did we have to get a book?
Said there was no book for this class.
Huh.
Well, I'll go into the...
For mine. Oh, wait. Maybe there is. At one point, it was attached to my math lab. To go through my math lab to find the chapters.
Oh.
It's changed.
Okay. Yeah, I don't really know what's going on.
I don't know. I'm not
Trying to
sure
find it,
what
but...
books, so.
Oh, here we go. Are you guys finding anything?
No.
E-text. Maya Pearson e-text. Trying to open something. Error. Either you have entered incorrectly your password. All right. I thought it might be the My Math Lab Pearson e-text.
Yeah.
But when I tried to open it, it just said error. And it wouldn't let me.
Wait.
So if it's anything, it's that. But
Figure 5.2 has nothing to do with the spring. So, I don't know.
assignments, analysis, study plan, grade. Oh, here we go. Now I'm getting there. It doesn't have anything to do with the spring?
Not as far as I can see.
Did you go to the HTML ebook?
Yes.
Just bring just white
For the motion
for me.
of spring.
Oh well.
Because I found if you go into the multimedia library, like under my math lab,
Yeah.
then yeah, if you click on multimedia library and then it sends you to another link, then it takes you to pre-calculus functions and graphs. Look,
Oh, I see.
that you can the chapters and sections. That's where I'm at right now. I haven't really found anything, but maybe that's what he's talking about. I don't know.
Isn't that kind of a different realm, though? The like a spring.
Motion of spring.
I don't know, but the HTML ebook doesn't work on mine.
Does it say
The
error?
link doesn't. No, the link just doesn't go anywhere. It goes to an empty page.
Yeah, it did
That's
that
what
with mine as well.
I did that with mine, and now I'm clicking on. I think it says Pearson error. Either you have entered an incorrect username or password, or you do not have a subscription to this site. Maybe I have to. Let's see.
Aha, yes, I found it.
Where?
Okay.
Okay, so if you go to the multimedia link and then type in like the chapters, so go to like chapter 5 and then section 5.2. And then you have to press select all and then find now. And then it pops up with this other window of the book online. And then if you go to page 359, it's example 8. I don't know. Find it, but.
No,
Are you guys
it's not working.
like
Can I
logged
just read it
into?
off?
Yeah, I'll read it.
We can do it without all of us
A weight
finding.
a weight of a certain spring is set in motion with an upward velocity of 3 centimeters per second from a position 2 centimeters below equilibrium. Assume that for the spring and weight combination, the constant W has a value of 1. Write a formula that gives the location of the weight in centimeters as a function of the time t in seconds, and find the location of the weight 2 seconds after the weight is set in motion. Oh my gosh. Did any of you understand any of that?
Wait, what did that have to do with what we just did?
I don't know.
Wait.
That's what I was saying. Is like it seems like that's kind of a different realm.
Well, because it's like a sine and cosine kind of solution.
Is it?
Yeah, so I'll write down the solution because it has the answer and stuff.
Oh, it has an answer.
I know.
Do you want to read it one more time?
So a weight on a certain spring is set in motion with an upward velocity of 3 centimeters per second from a position 2 centimeters below equilibrium. Assume that for the spring and weight combination, the constant W has a value of 1. Write the formula that gives the location of the weight in centimeters as a function of the time in seconds, and find the location of the weight 2 seconds after the weight is set in motion.
No idea. What's the answer?
Okay, so let's see. It's 3.6 centimeters above the equilibrium position. So if t equals 2 seconds, then x equals -3 sine. Okay, this is really, really confusing. I'll just write it out. So this is like the initial formula. Hold on. That they use. That. And so t is 2 seconds, and x equals -3 sine times 2, because then you use 2 to substitute for the t in that equation. Did you guys get it? Do you want me to hold it up again?
Yeah, hold it up again.
Okay. Let's see. So it's x equals -3 sine t plus 2 cosine t. And then if t equals 2 seconds, then you just plug in 2 for the t. Then that equals -3.6 centimeters, which is 3.6 centimeters above the equilibrium position. It just switches negative to positive. But I have no idea how to set that up.
Well, maybe Brother Johnson. I think that's his name. Maybe he'll send out a video on how to do that. Because I don't know, I'm pretty lost with it. It seems like, honestly, this problem is something that we haven't necessarily learned about yet. Maybe there was something that I missed from the reading. I Learned 3.0 is, really confusing and stuff, but I think maybe a lot of other students are probably going through similar problems, and if anything, he'll just post a video explaining
definitely. It. And I'm thinking that it's kind of like, I don't know, I feel like it might be drawing like a triangle, kind of, like once it's set in motion, it's like 2 centimeters above versus 3 centimeters. I don't know, maybe that's just, doesn't it see it? And then, like, you use the sine and cosine off of that. Like, if you were to draw a picture of it in motion, then it would be... Does that make sense?
Yeah, I get what you're saying.
Okay. But I really have no idea, so hopefully Brother Johnson... Isn't his name Brother Jordan?
Oh, it's Brother Jordan, I think.
I think it's Jordan.
Yeah, I call him Brother Johnson. I'm cool. Yeah, Brother Scott Jordan. My bad.
So yeah, hopefully everybody else is as lost as we are.
Hopefully.
Hopefully.
Yep. I have a quick question before we end. I saw one person on that, that sheet, that Google Docs or whatever, with a bunch of sign up like for groups that we did. There was one person that said that he could meet anytime, and he was the only one in his group.
Oh, really?
And I was wondering if I should email him or something and say, hey, if you want to join our group, you can.
Definitely.
Yeah.
I'm fine with it. Yeah, that's it. More the merrier, right?
Yeah. But yeah, I'll shoot him a message and stuff, because I don't know how he completes his assignments, like Google Hangouts on air, if he doesn't have anyone to hang out with on air. But anyways.
Yeah. That's kind of funny.
Cool. Well, thanks for meeting up, guys.
No problem.
Is there anything that we missed? Is that everything that we needed to do?
I think that's it.
Are we doing the next one?
Yeah.
We have to do another one
work?
Thursday.
What did you say?
What days work for you guys? Like, do Tuesday and Thursday work for you guys, or Monday, Wednesday is better?
I don't care.
Probably Mondays. I mean, I could do either, really. I could do Mondays or Tuesdays. like for the first due date, and then there's like the second due date that we have to do the same thing, right?
Yeah.
On Thursday. So would it be easier if we just got it done like a day before? Like
Yeah,
meet up
probably. And if something comes up, we have one day to buffer it,
Right.
and stuff.
Yeah.
So should we shoot for Monday, Wednesday?
Yeah.
Okay.
Yeah.
And,
That'd be good.
I kind of have to apologize in advance. My work schedule is all over the place. So some days I'll get off at 5, and some days I'll get off at 7 Central Time. And so it all depends on that. I'm trying to keep it pretty regular, but I'm just really sorry.
It's all good.
That's fine.
It's all good. Well, thanks for meeting, guys. I'll go ahead and stop the broadcast, and if you want, Holly, I can send you the link or something so you could post it or something. Or
Yeah, they better do that because I got an email about I'm supposed to send it.
really? Okay. I'll try and figure out however it is to do it, and I'll send you whatever you need.
Okay, that'll work.
Alrighty, see you guys. Have a good night.
See ya.
You too.